Here is section 7.3, video 2, absolute value inequalities. And let's start just with the inequality. Absolute value of x minus 7 is less than 4. As before, you start with the equality. I say absolute value of x minus 7 equals 4. And what I like to do for absolute values is once I have the absolute value by itself, that means either x minus 7 is 4 or x minus 7 is negative 4. Because when I take the absolute value, it'll make both of these positive. So if I do that, I have x equals 4 plus 7, which is 11. And if I do that, I have x equals negative 4 plus 7, which is 3. So my two boundary points are 11 and 3. And then I can graph because I know generally what an absolute value looks like, and that's shifted left 7. So it looks like this, and there's y equals 4. And I wanted it less than 4. So there are my boundary points. That's 3 and 11. And so it must be between 3 and 11 to be less than 4. Or I can use test points. And so I'll pick a test point smaller than 3, between 3 and 11, and bigger than 11. So I'll use x equals 0, x equals 7, and x equals 12. So I put x equals 0 in, I have 0 minus 7. In absolute value, that's 7, which is bigger than 4. So that's not going to work. If I put 7 in, I get 7 minus 7, which in absolute values is 0, which is less than 4. So that works. If I put 12 in, I get 12 minus 7 in absolute values, which is 5, which is greater than 4. So that doesn't work. So the only test point that works is between my endpoints. So that must mean my interval that works is the interval between the test points. All right, if you are given a more complicated absolute value, let's do less than or equal to 6. Inequality. Step 1 is you first solve the equality. This is definitely a trend. Equals -6. Now you need to isolate the troublesome part. Isolate the absolute value. And so to do that, first I'm going to add 14 to both sides. And I get -2, absolute value of 2x plus 3 equals -14 plus 6 is +8. And then I divide both sides by -2. And I get the absolute value of x plus 3 equals -4. And you should always stop when you get here and ask, does this equation make sense? Because the mistake is to say, okay, that means x plus 3 equals 4, x plus 3 equals -4. But that's not true. You cannot have an absolute value equal to a negative answer. So there is no x value that works for this equality. And what does that mean? Well, that means if I draw a graph, that's going down. And it crosses below. So my options are either it's always below y equals -6, or it's always above y equals -6. If it never touches, we know an absolute value graph looks like this or this. So it's either always below or always above. And how do we know? Test a point. So I'm just going to test any point. And if any point is less than -6, then I know my absolute value function is always less than -6 because it never equals it. And if any point gives me a number bigger than -6, then I know my whole graph has to be above y equals -6. So usually the easiest point to test is 0. So I do -2 times the absolute value of 0 plus 3 minus 14. That's -2 times 3, which is -6, minus 14, which is -20. That's less than -6. So that tells me my function is always less than -6. So the set of solutions is all real numbers. I'm in this scenario here where it never even gets up to -6. So it never touches, so it's below for all values. All right, what if we have something that behaves a little more nicely? Let's do almost the same. I had to pause the video for a little bit, but I'm back. So now we're faced with solving this inequality, which I wrote to give us a chance to see a slightly different absolute value inequality. Step 1 is to solve the equality all right, -2x plus 3 minus 11 equals -23. So I'll add 11 to both sides. I get a -12. Divide both sides by -2. And I get absolute value of x plus 3 equals 6. So I stop. And I say, does this make sense? Yes, because that's a positive number. Absolute value of anything has to be positive. So I can continue to say either x plus 3 equals 6 or x plus 3 equals -6. And if that's the case, then x equals 3. And if that's the case, then x equals -9. So now I have my solution points where it's equal. And I need to find out, well, when is it greater than or equal? And maybe I think about, all right, it's negative, so it opens down. So whatever that line is, it must have crossed here and here. So it should be greater than when I'm between those 2 points. But maybe I don't remember, or I just wanted to play it safe. So I can stick -9 and 3 on an interval, and I can test points smaller than, between, and bigger than. So if I put -10 in, I get -2. That is -7. Make it a positive, because +7 multiplied by -2 gives me -14 minus 11, which is -25, which is less than -23. If I put 0 in, I get that's -6 minus 11, which is -17. That's greater than -23. And if I put 5 in, that's -15. Wait, -16, sorry. -16 minus 11, I think it's -16, 8. Yeah, there's -27, which is less than -23. So I needed it to be greater than or equal. So it's only when it's between, but since it's equal, I can include those endpoints. So my solution is -9 up to 3. That's how you solve absolute inequalities. End of recording.